So a scatterplot kind of looks like a line graph in that you do plot the points, but the only difference is most of the time you don't have a line when you're looking at scatterplots. Sometimes you do have a line going through that. It's called a line of best fit, but we'll talk about that a little bit later on. So a scatterplot is represented by a whole bunch of different graph points. These are coordinate points. And you have positive, negative, no correlation, and there's also something called constant. There's a constant correlation. And so we're going to match these up. Notice that these points here, they're scattered. That's why it's called a scatterplot. They're scattered everywhere. There's no kind of pattern or anything. This one here, the dots are scattered, but they all kind of seem to be going down in this downward motion this way. This one, they're scattered, but they all seem to be going up in this upward motion. And then a constant would all kind of be going in a straight line this way, horizontally. So no correlation. This would be a no correlation because they're just all over the place. A positive correlation and a negative correlation would be one of these two. If you think about this going down and this going up, when it goes down it will be a negative correlation, and when it goes up it's a positive correlation. And then a constant correlation would be a correlation that it's a horizontal line. So this is a constant correlation here. So with a negative correlation, this is your x-axis here and this is your y-axis. As the x-axis increases, so like this would be the number 1, 2, 3. This would be 1, 2, 3. So what happens is as the x-axis increases, so like here we have 3, 1, and we would have, or I'm sorry, let me back up. If we would have 1, 3, then we would have 2, 2, then we'd have 3, 1. So if you notice your x's are increasing. As the x-axis increases, the y-axis is actually decreasing. And if we wrote that down as some of these points, just so you can see a visual, this point would be about 1, 3. This one would be about 2, 2, and this would be about 3, 1. So if you notice, as your x-axis, this is your x-axis here and this is your y, so as your x-axis numbers are increasing, your y-axis are actually decreasing. You're going from 3 to 2 to 1, and that's what makes this negative correlation. So if I asked you to predict for the number 4, you know that the 4 would be less than 1. It would probably be down here somewhat, probably be like 0.5. With a positive correlation, it's the opposite. Here we have 1, 2, 3, 4, 1, 2, 3, 4. This point here would be about 1, 1. This point here would be about 3, 3. This would be about 4, 4. So again, looking at your x and your y, as the x-axis increases, we're going 1, 2, 3, 4. So as the x-axis increases, the y-axis is also increasing 1, 3, and 4. So there's a difference. If the x-axis increases and the y decreases, it's negative. If the x-axis increases and the y-axis also increases, it's positive. And then with a correlation, it's just with a constant correlation, it just goes straight. So again, what I would like you to do is go ahead and pause the video and try these yourself. So on this one here, as the x-axis is increasing, the y-axis is also increasing. This is a positive correlation. As the x-axis increases, the y-axis is decreasing. This is a negative correlation. And here you just have these random, I mean it's a circle, but it's not like they're going up or going down. So this one, there's no correlation at all. So this would be a no correlation. Here I should have put an X. So how do you know where to place the line of best fit? The line of best fit is going to go where all the points, where you have the equal number of points, and we'll talk about what this is in just a second. For the equal number of points on top of the line as well as below the line. And what a line of best fit is it's a line that goes through the graph, and it kind of shows more or less where the line would be. So the line of best fit here is, it's not going to connect the dots. You're not connecting the dots. You're actually making a straight line, and you want it to be where you have it, most of the or half of the line, the dots above the line, and half the dots below the line. So here you have 4 dots above and 4 dots below. So this would be the line of best fit. If you happen to get dots on the line, points on the line, then that's great. Here, if you notice, you can probably go through these 5 here. So if we go through these 5 points here, we still have 1 on the bottom and 2 on the top, and that's about halfway. You want about the same number of dots on the top as the bottom. So that would be your line of best fit. Here, you can't have a line of best fit. There's no correlation. If you look at this one also, there's no correlation. This one here, your line of best fit would be, remember you're trying to get is about halfway through the point. So here, if I drew my line here, I would have 1, 2, 3, 4, and then 1, 2, 3, 4. So my line of best fit for this one would be about right here, because you have 1, 2, 3, 4 above it, and 1, 2, 3, 4, 5 below it. So that's about halfway. And you're just trying to get the best fit. It's not going to be a perfect fit. This one, I can probably get these 2 points right on the line. And again, you don't have to have any points on the line. You just want to get it about equal. Here we have 4 points above and 3 points below. So that's about even. And then this one here, if we did it, it would be right here in the middle, where we would have 1, 2, 3, 4, 5, 6 below it, 1, 2, 3, 4, 5, 6 below it, and then 1 on it. So the line of best fit is a line that you can draw through the points, where you have the number of points on the top of the line are about equal to the same points below the line. So now what we're going to do is we're going to identify these data sets as either having a positive, a negative, or no correlation. So this is the best way to do it, is to always assume that the first thing is going up, and then you have to figure out, is the second thing going up, going down, or it doesn't, there is no way to tell. So as the number of hours a person has driven goes up, remember we're always going to assume that the first one goes up. So as the number of hours a person has driven goes up, what happens to the number of miles driven? So as a person drives more, the number of miles that they have driven increases. So if you drive for 2 hours, you go 4 miles. If you drive 4 hours, you might drive 6 miles. So because this increases and this increases, as one of them increases and the other increases, that's a positive correlation. The number of siblings a student has and the grade they have in math class. So siblings is how many brothers and sisters you have. So as the number of siblings a student has increases, the grade that you have in math class, what happens to it? So this is saying if you have 1 sibling, what happens to your grade in math? Or if you have 5 siblings, what happens to your grade in math? Well, one doesn't relate to the other. There's no correlation between the two. There's absolutely no correlation. So this would be a no correlation.